those who are joining, sorry about that. For those who are joining us for the first time, you are welcome to our webinar series. This is our RISE webinar series that we host bi-monthly. RISE is a non-profit social enterprise that operates in Lesotho. We are in a landlocked country in Southern Africa. We focus mainly on economic development through job creation, skills development, and entrepreneurship, specifically in the built environment through a fellowship program called In Local, uh, which is a design, build and entrepreneurship program for graduates who have studied architecture, construction management, civil and electric engineering, plumbing, and carpentry, amongst other disciplines. I can say a lot about the fellowship, but for now, if you allow me, let me introduce Daniela, who is the co-founder of Rise International and our executive director. And she will hand over to Hector immediately after her remarks.
You're muted, Daniela.
It's okay.
No, I cannot hear you.
What did we do?
Okay, can you hear me now?
Yes. No, now we cannot. So we hear you for a second and now you disappear.
Okay, can you hear me now?
Well, yeah, no. Yes, try again.
Yes?
Yes, now that is.
Yes. Okay. I'm logged in from two devices. I'm not sure which is working, so we'll keep them both going. Good morning, good afternoon, everybody, wherever you're logging in from. It's a real pleasure to be at this moment after several months of planning this project. And this collaboration with UCL, the University College of London, came as a result of about 18 months of research that RISE was involved with, researching indigenous as well as alternative low carbon building materials, including sandstone, thatch and grass, sheep's wool for insulation, hempcrete, compressed earth blocks, and recycling materials. And we did all of the sort of desk research into these materials to look at their availability, feasibility, sustainability, and costs, to try and reduce the amount of building materials that are imported from South Africa into Lesotho, as well as try and reduce the carbon footprint. We then collaborated when we met Professor Hector Altamirano, sorry for that, Hector, in January of 2023. We started the conversation about the opportunity of his students doing some research on using some of these materials in different climates, different climates in the Highlands of Lesotho, because Lesotho being a very mountainous country, we have different sort of extreme climates. We have about 5 or 6 months of very cold weather in the winter months, and then very hot weather in the other 5 or 6 months. So it was great because we are looking for solutions for affordable housing. And so it was very beneficial for us to have Hector and his students working on the different configurations of the different materials. And it was up to the students to decide which materials they wanted to work on and which region, both in Maseru, which is in the lowlands, but it's still quite high at 1,300 meters, and up in the Mokhotlong area, which is over 3,000 meters. So that just gives you a little bit of background of how this partnership came about. And the students just finished their projects, and I believe we have 3 different groups who are going to be presenting to us today. And there were other groups and other students, but we don't have time to hear from all of them. So I'll now hand over to Hector, who'll give you a bit more background before then handing over to the 3 different student groups. Thank you so much. Over to you, Hector.
Thank you, Daniela, and thank you, Chris, for organizing this webinar and this event, and for giving us the opportunity to present our work and the work that actually the students have done. We are part of UCL, University College London. We are in the Institute for Environmental Design and Engineering. And as such, this is one of the oldest. It has more than 50, 60 years of existence. And this is one of the oldest MSc programs that are in the world that look at energy efficiency and sustainability in buildings. We receive students from all over the world, and which is one of the beauties about this program, that are interested in understanding more how to design more efficient buildings. And the particular module that I lead is called Building Solar Design, that for many years it focused mainly on the use of the sun in this design of passing architecture. However, lately, what I have been trying to do is to give the student other challenges. And for a couple of years, we were working in other locations in the world, in Washington. Then we moved to Tanzania. And now, well, because of the link with you, Daniel, and with Rice, we decide to, well, let's experiment, experimenting, let's explore what will be the result if the student try to help the work that Rice is doing. So as you correctly said, I mean, the main challenge for the student was to try to use these 6 materials. Was just, I mean, they decide if they're going to use it, if they're going to be a combination of them. And this is a project that lasts for 3 months. Within the project, they have to do a number of activities. So they just finished the project, I think, at the end of March, and then they have to be marked. And people from RISE that selected these 3 projects. Wasn't me. They were the one that came to the poster presentation that we have here at UCL. And they told me, well, you know what, we think that these 3 projects could be quite relevant for RISE. So this is how, well, I contact the students, and they kindly agreed to give this presentation. So what I have asked them is to prepare a 10 minutes presentation each group. And so then we can probably have some questions for them, whatever the question you may have, Rice or people that is attending this webinar. What I'm going to do here in the chat, I don't know if people can see this. I'm going to put a link to the master program that the student belong to, which is the MSc Environmental Design and Engineering. So without more to say, I'm going to pass the microphone to group number 2. So if you can share your screens. So we're going to go the 3 presentations and then question and answers.
Hey, hello everyone, and thank you for this space. We will present our project, House in Mokhotlong, Lesotho. These are 2 renderings of our final project, the front and the south facade. And as part of our initial research, our site was Mokhotlong, which is the mountain region of Lesotho. It's classified as a subtropical highland climate with warm summers and cool, dry winters. And in winter, it can be very windy with an average temperature of 9.4 degrees Celsius. In the graph, we can see the annual temperature distribution. And as we can see, most of the time, it's below 18 degrees, which is relatively cold. And for the site, we selected this This lot in the center of Mokhotlong is relatively close to the airport, and we selected this site because it has unobstructed views to the north, which was beneficial to our project and what we were trying to achieve. As part of the initial research, we wanted to look into vernacular architecture from Lesotho, and we came across these two initial concepts that we considered for our design. The first was rondaville. Rondavilles are circular houses that are designed to efficiently resist the harsh climate of Lesotho, and they are often decorated with vibrant colors and intricate patterns. And the second concept we came across was this concept of sky space. In Lesotho, homesteads are usually expanded by building additional structures rather than adding on to the existing one. And this creates an external circulation space known as sky space. We found this concept very interesting. And even if for our project we didn't design additional structures, we wanted to bring this idea of a sky space into the original layout. The next part of our initial research was building materials. We had a list of materials that we wanted to investigate, and we prioritized low carbon, low cost, and availability. And we listed them and color coded them based on which was more uh, efficient for our project. We selected concrete earth blocks, thatch, and sheep wool for insulation because of their low cost and availability and low carbon. And the final part of our initial research, we started out doing a shoebox analysis in which we tested different types of materials for the wall and for the roof, different types of glazing, also window to wall ratios, shading, and orientation. And in the diagram, we can see what we selected as the best options for our design. For example, the final orientation, we concluded that the optimal one was northeast because this is where we would get more solar gains that would be beneficial to keep internal comfort in the dwelling during the cold winter months.
So for the environmental strategy, I want to stress 2 points. The first one is the layout of the building, and second part is the isometric diagram. So since we have studied the vernacular architecture, which is the round shape of the building in the local area, and also the sky space, so we try to apply these two strategy into our building. So that's the reason why here we got a sky space in the middle of our building here, and the building's round shape. And also we reorganize our plan of our building. So as you can see at the right part of the plan, we put most glazing in the northeast of the building. Just as Espen has mentioned, we got the best orientation to the northeast so that the thermal comfort in the living room could be in a good level. The people inside could feel comfortable. And also the effect of the rendering you can see at the right shows the entrance and the sky space. So this part is about the seasonal section. You can see we in the thermal mass we use CEB. It can absorb the heat in the daytime and release heat in nighttime, so that people in the bedroom and living area could feel quite comfortable. And glazing, you can say the window play a key role in also in the thermal comfort. It not only captures solar heat, but also it introduce the fresh air and also exchange the exhausted air to the outside space. And for the initial and final model, we do different iteration for our building. At beginning, we try to do a reverse roof building, but for the buildability, it's a little bit hard because the snow load could be quite high and it will crash the roof. So we just change into pitch thatch roof with central skyline. And then we not only thinking about the buildability, but also the environmental improvement. We adjust a little bit about the building fabric and ventilation schedule. And finally, we optimize the embodied carbon in the building. So we change some materials and reduce the walk thickness to achieve that.
So in the next part is house performance. So here is the results of our initial and final models. But first of all, I want to show you the comfort temperatures of each area. So for the living area, we find that the guideline of natural ventilated house, the comfort temperature should be between 18 to 24 degrees Celsius. And for the sleeping temperature, it should be between 17 to 24 degrees. And also, as you can see from the initial model, we have a lot of co-issues, as you can see in the color of blue. And we try to reduce each issue in each iteration. That's why it's resulting in our final model by adjusting the materials and ventilation schedules like my friends mentioned before. So we want to show you how we use the local materials in our model. So here is the components of the final model. So the first one is we change the wall material layers. So here is the external wall layers of the initial model compared to the final model. As you can see that we changed the layers of CEB to make the most use of its abilities of thermal mass. And also we changed gypsum plasterboard to clay plasterboard because clay plasterboard has abilities of thermal mass as well. And also gypsum plasterboard, it has high embodied carbon. And in the second part, as we face a lot of co-issues, that's why we implement sheet wool for the floor insulations. And here is the layers of the floor. And also to achieve the results in our final model, we also adjust the window opening time. So for bedrooms, it need to be partially open throughout the night. And for the living area, it can be varied by the temperature, but basically it's like open the windows when comfort and close when cold. And this resulting in the achievement of our final model to increase overall indoor thermal comfort hours in all spaces and also reduce material use and embodied carbon. So because of our time constraint, that's why we cannot test all the strategies, but we want to suggest some improvement for future considerations. So to deal with cooling issues, we can utilize passive heating strategies such as trumpet wall and thermal wall, like the picture in the left. And also we can consider the building design to capture more sunlight. This can be done by changing the locations and size of the sky window in bedroom 1 and 2. And also, as the overheating issue arises in our final model, even though it's not our main issue, but to deal with this issue, we can utilize passive cooling strategies such as external shading and nighttime ventilation. Thank you for listening. We hope our findings is useful for you more or less. Thank you.
Thank you very much, Mamai. So can we go to group number 3, please? If you can share your screen.
Okay. Hello.
We can you change it because we can see your notes.
Oh, sorry. Are you still seeing?
Let's see. We can see PowerPoint. No, still we can see the yeah, now that's perfect.
Okay. Hello everyone. My name is Aiman and I'll be representing group number 3. And today here with me is also my colleague Gokan, and my other two members are currently not available, Liwan and Mary, due to some other commitments. So for group 3, this is this image here is how our building looks like. So it's quite simple, and then we try to keep it as simple as possible so that it can further be replicated, and which I'll explain a little bit more further on. So starting off, this is our approach. So first of all, we look at the site selection and the indoor comfort criteria, and then we did a little bit of shoebox modeling, which then translate into the architectural strategy, initial design, and final strategy. And in between the initial design and final design, we have an iterative process where we test a lot of different things, and to see how we can further improve and make sure that the building is performing as how we intend it to be. Okay. So for example, in terms of context research, how we approach it first, we did a little bit of context research in terms of demography and culture. We try to look into the vernacular architecture in Maseru, and then which led us to finding the design of the Lesotho hut, which at a glance give us sort of like an understanding about how local materials could be used, and also how buildings are designed, especially dwellings are designed in Lesotho. And then we also look into the in terms of the clothes and appearance of Lesotho people, which led us to a bit of understanding how people would actually adapt to the cold climate and all the cold seasons in Maseru. And then we look a little bit into like school timings, and also the different other building forms in Maseru. And then from there, from that research, we came up with an occupancy schedule. So this is the occupancy schedule that we assume for the occupants of the house, which takes into account the different users, including the parents and also the kids. Okay. And then, like the previous team, we also did a little bit of background research on local materials, and this is actually including a little bit more than the 5 materials that were given to us. And then this is it for insulation, and then this is for roof, which when we were progressing with our design, these are sort of the things that we considered throughout the design, especially in terms of cost and also thermal performance. And then this one is for the wall. And then moving on to site selection. So when we were doing our demographic study, we found that the population of Maseru or Lesotho in general are mainly Christian. So we figured it would be best if we can find a location that is nearby a church, as well as also nearby a school, so that it'll be easy for the parents to send off the children to school, and so that the grandparents who are also taking care of the children would be easier to come to the house, and it's reachable. So we decided to select the site at Masoweto. I hope I'm pronouncing that right. And after selecting the site, we look into the pollution in the area, which is the NO2 intensity, and also PM 2.5, which if we look in this diagram, it shows that the NO2 intensity is between 0.0 to 0.4 parts per billion, and also the PM 2.5 is somewhere around 5 to 10 micrograms per meter cube. So yeah, we look into this, and then we also look into the climate analysis, which was quite explained in the previous group as well. And then we look into the windrows, where wind would come. And all of this climate analysis was important to us because we then use all of this information to actually sort of start our initial criteria, the indoor comfort criteria. And for our group, we calculated the thermal comfort range based on ASHRAE 55 adaptive model. And we found that the range for the cold season to be 18.6 to 26.6 degrees Celsius, and hot and rainy season would be 22 until 29 degrees Celsius. And then we also set a little bit of other environmental targets, including humidity, noise levels, and CO2 levels. And then based on all of the information that we've researched, we started doing our shoebox modeling. And shoebox modeling is basically where we tested out a bunch of different things to see which configuration would be best for us to start our design. And then we found that so the blue are what the best simulation is for each of these categories. But then when we were selecting to start our first design, we didn't actually just based on getting the best thermal performance out of the building. We also considered other factors, like I said, the cost, the availability of the materials within the region, and a few other things. So we found that facing north is the best for us. And then we have the long and narrow shape, which is quite a simple shape, I would say. And then for the roof, we found that thatch to be the best performing. And that is quite good because it is a local material that we can use. And also for walls, we found that fire bricks, which is the typical bricks, to be performing a bit better than, for example, like the local material CEB. But we decided to go with CEB and also plastic bricks because that is more available, and the differences were not that too big that it would be a problem. And then same goes with the insulation. And in terms of thermal mass, we decided to stick on medium weight thermal mass, and in the glazing ratio, we tested out in different different building facades to see which ratio would fit us the best. And then from that, we came up with 3 design pillars: familiarity, replicability, and adaptability. Familiarity is just so that the design is quite familiar to the local population. And this is important so that the design is not too extravagant. It's not too weird in a way. And then replicability is so that since we're working with rice, we wanted the design to be replicable as much as possible, so that if rice is going to replicate the project in anywhere within Maseru that has sort of like this same microclimate, it will be doable. And in terms of that adaptability, we try to think about different sets of occupants as well, not just the sets of family that was given to us through the brief. And because having this kind of thinking actually gave us a little bit more constraint or room to think about what will happen to the house when the families goes out, or if it's changed with another set of family, and so on. And then from there, this is sort of like the basic idea, the massing of the building. We have double story, public and private circulation, and then we have an outdoor balcony, initially some shading, and then it changed to a conservatory due to some reasons, which I will explain later. And then this is the layout. So basically the public zones will be on the ground floor, and private zones are mainly on the second floor, with the twin bedroom being on the first floor. Twin bedroom is the kids' room in this project. So this is how the initial design looks. It's quite simple. So it's just this is the south facade, and then here we have a balcony on the south facade for the occupants to enjoy sitting on, being shaded from the sun. And for initially, the environmental strategy is like this, where most of it is like a combination of cross ventilation and also stack effect. But then we found that this wasn't actually that effective in terms of a ventilation strategy, because of the low wind speed because of the low wind speed, which was not enough to drive the cross ventilation effect. So this is the build up. In this early design, we've already focused on trying to use as much local materials as possible. But some of this has then changed throughout the design, due to trying to make it better performing, or some other reasons, because of cost or availability. And then this is the final design. So we have thatch roof, which what we started off with in the initial design. And then we have this conservatory on the north. So initially this was a shading, but then because we see that one of the problems we were facing was the spaces on the ground floor was being cool. So when we tried out having a conservatory on the north facade, it actually helps to warm up the ground floor spaces by making it into like an indirect solar gain system. And then for the walls, we have CB and sheep's wool, and we also have a chimney, which actually helps to facilitate the stack effect ventilation. And then the chimney is designed to have with a metal roof, so that it gets hit when the metal roof gets heated up during the day. It helps to further drive the stack ventilation effect. And yeah, this is our final environmental strategy. So as you see, most of it is driven by stack ventilation. And then we also actually have thermal mass on the walls, and actually a little bit on the ground floor as well, because we are using sandstone. Yeah, this is the material buildup. And the main changes here was on the ground floor, where we changed from plastic bricks to just using sandstone and AEC. So in terms of performance, from the base case to the final design, this is how it ended up as. So the base case, we can see that we have overheating problems and also underheating problems, which means that the spaces are cold, and then also a little bit of CO2 problems. But then after we've made changes to the design through the iterative process, we then ended up with having just a slight overheating problem, whereas we still have a little bit of underheating problem, but it has decreased since the base case. And that is all from us, Group 3. Thank you.
Thank you very much, Aman. So let's move to group 7.
Thanks, Hector. Myself, Shizhen, and Sibyl on the call now from Group 7. I'll just share my screen.
Sorry, I'm not so sure if it's me, but I cannot hear you really well.
Okay, now.
If you can probably talk closer to the screen.
Yeah, sure. Sorry, is that not very clear, Hector?
Then now it's much better. I don't know how others can.
I'll keep facing in this direction. Hopefully, it'll work. Brilliant. Well, look, thanks everyone for coming on and seeing our design and letting us talk through, how we got to it and what sort of led us to our final design here and how it performed. So, in designing our house, there was our home. There was 4 kind of things that drove us, I'd say, on the way through that design project. Firstly, the look and feel. I think we really wanted this to feel like a home that both fitted in Lesotho and also, fitted in with the habits and uses of real estate within Lesotho itself. We had this focus on the materials, particularly on indigenous materials, and how we could use that within our design, whilst also looking to achieve the other goals that we were hoping to do. Making sure that the environmental design of the building worked well with the climate throughout the year, and just through sort of trying to keep design simple but effective on that front. And then this final point about simplicity: could this be something that could be replicated? Was it a design that local builders could easily put together, that could source the materials for, that could be replicated around the country? So just to show you where our design got to in the end, this is the final rendering of it, and I'll talk you through how we got there now. Thinking about look and feel, there was a few kind of real key things to us that I'd emphasize in the way that we came about our design. I think the other groups have mentioned the idea of the sky space, and this is something that we really liked. We wanted to make a really central point to our building. This is a public-private building because of the childminder nature of it, but also that seemed to be reflected in the indigenous architecture that we saw in our research. So we tried to make the center of our design a public-private room, which we called the childminder's room for the purpose of this, which ran the full length of the front of the building, benefited from the most light, and would be the entry point to the property, but also where most of the time was spent for the occupants, and therefore we kind of focused a lot of how we made that room work from an environmental point of view and a usage point of view as a real key part of the strategy. So that led to that room being north facing. It led to us wanting lots of glazing to try and let lots of natural light into that room, but also mitigate overheating and other things that would come up as a result of having that room used in that sort of way. Other points that we really wanted to focus on from the local aspect was really, I think sandstone as a material really appealed to us, with it being indigenous, and come on to the research sort of showing that actually there was an abundance of the material, but maybe it wasn't fully utilized within the country. And also the research found that it wasn't actually tremendously more expensive than brick, and perhaps a higher usage of that material in the country could bring down the price and have a number of other benefits that went with it. Other things that we looked to replicate, we and actually didn't quite make it into our final design, but I think, you know, if we were looking to this into the future, you know, would go with it. We loved some of the patterns that we found in within the local architecture, and also this axis of symmetry point. You know, the symmetrical nature of the buildings that we saw there. So just looking at materials and what we ruled out, what we ruled into our design. I think we looked in detail at the materials listed here. So looked at thatch roofs, hempcrete, and also at sort of renewable building materials, and considered how potentially they could be used within the design of the building. As well as these three indigenous materials here, the sheep's wool, sandstone, and compressed earth blocks. I think while we liked the thatch roof, I think when we were thinking about our simplicity, the durability of that material and use in roofs, especially on a sort of 2-story building, that the sort of 3 to 5 year life cycle before kind of maintenance was needed, we ended up deciding to rule that out in favour of concrete tiles, which we actually found to be, you know, more environmentally friendly than other materials that we looked at for the roofs at that point in time, especially with sort of rainfall and potentially snow being incorporated into what that roof would have to deal with. I think from the renewable materials that we looked at, and we looked in quite a bit of detail about how they could be used, where they've been used in other projects, and actually, I think we just found that the materials, you know, in all sorts of different uses, were just not reliable. You know, that we doubted at this stage that there would be a supply of those materials, and you know, that could create that sort of reliable material structure, but also that even where there was, you know, that a high density of those materials available, that actually in all sorts of different ways they didn't have that reliability to use in a building such as this. And then hempcrete, we found to just have the expense but not actually have the strength to match up to other materials that we use there. Sandstone I've mentioned. I think you know, the sort of long life that came with the sandstone, the thermal mass benefits it had, and actually the low carbon footprint that was potentially there, you know, where local sources could be used, we were really encouraged by. Compressed earth blocks, you know, there was the potential issue if we used those exterior walls that they would erode, but actually cheap and low carbon emissions that come with them, which we thought was a real benefit. And then the sheet wall side of things, you know, that seems to be a very sensible material to use for insulation. So just, you know, very quickly where that fitted into our design, we used the compressed earth brick for internal walls where they wouldn't be exposed to weather, and then the sandstone and sheet combined together on external walls to both have that thermal mass on the exterior and long life cycle, but have the insulation benefits of the sheep's wool within. In guiding our environmental strategy, like the other groups, we carried out our shoebox analysis, which led us to go to a cuboid space for the shape for the building, which, you know, was a bit of a shame in some ways because some of the round architecture in Lesotho was very interesting. But again, from a simplicity point of view, we found it more difficult to design rooms and to use environmental strategies with that shape. It also led us to have a north orientation, that we wanted to find a way to increase our the level of glazing. So we looked at secondary glazing rather than double, to again keep that simplicity within the design, and a real focus on shading to improve thermal comfort within the building. On those environmental strategies, the key ones are here, and, you know, through iterations and through testing, you know, found a good balance of insulation, that secondary glazing point mentioned, the right ways to use thermal massing, For example, we had originally had quite a lot of thermal mass on the second floor, but actually we decided the benefits that came with that didn't really outweigh the costs that came with the additional structural work. And then I think the big point for us was around shading, getting that natural light and solar gains into the building during the winter, and then finding a way to mitigate them through shading in the summer. So you can see the sort of key iterations that we carried out here. And I think the key for all of them was to try and keep things as simple as possible. So you can see it's mostly about changing materials, and then adding those environmental strategies that I mentioned in the previous slide there. And I think from a results point of view and the childminder room, I think through our iterations, we went from an predominantly overcooling problem to actually managing to get the heating into that room, which helped during the winter months, and then found ways to mitigate that overheating during the winter through the way that ventilation control was carried out, shading was carried out, and that insulation and glazing point really being the focus. And then finally, just on thinking about some of these simplicity points, it's not something that we got to in the end, but I think there was a real focus in our group for where we'd want to go with further work, really about sandstone and how that could be used, because the level of the sort of abundance that in the country around it, and the fact that if it was used in much more construction within the country, you'd think that costs would be driven down, but also you'd potentially build a skills base amongst contractors who would be putting together these buildings and carrying them out repeatedly. We sort of looked to, if we were going to expand our designs here, whether we could create sort of quite a design that incorporated a sort of a grid program into it, so that actually sandstone could be cut in a more uniform way in order to be able to use it most effectively, and also to make designs between different buildings very straightforward in the crossover, because that material will be used and cut in a very straightforward way. So it was a concept that we were thinking about for the next sort of stages of thought. Brilliant. That's the end of our presentation.
Good, thank you very much, Henry. So Daniela, Chris, so this is the end of the 3 presentations. It would be great if you have questions, you can ask them.
Thank you so much, guys. Those were really insightful presentations. I have maybe 2 questions. Firstly, I would like to ask if the program actually from the first presentation, maybe there was a point that I didn't get it, but I would like some clarification maybe on the sustainability of the building, looking at the fact that there's very hot summers and very cold winters in Lesotho, especially in the Highlands.
Yes, for our location in Mokhotlong, we studied the climate, and most of the time it was relatively cold. So we were dealing with overcooling rather than overheating. So our design focused on bringing solar gains and taking advantage of the sun to provide thermal comfort through the materials and through the design of the house that we proposed.
Okay. No, thank you. That's clear. I think my initial other question had already been answered, so I'll hand over to Daniela to maybe say a few if she has any.
Thanks, Chris. Yeah, I've got a few questions. My first one goes to group 7. You looked at different materials on the roofing. If I'm not mistaken, you concluded that roof concrete tile was better over thatch. Is that right? And if so, can you explain the reasons for that?
Yeah, thanks, Daniela. I think when we looked at the two, the real driver for it was that maintenance point. I think where there'd been thatch in the local architecture, mostly that was on single-story buildings, and we were finding the best way to design our building was to have it over 2 stories so that we could have plenty of north-facing windows to benefit both the bedrooms and the childminder's room, with which was kind of the main focus of our work and the areas that would be occupied the most during a 24-hour period. So having that 2 stories and then having a material that needed maintenance every sort of 3 to 5 years, I think was something that we wanted to avoid from a simplicity point of view when we were using those materials. Shishen, so was there anything to add on the actual environmental performance of the thatch roof? That was quite an early decision that we made, so I'm not sure if we've got stats on how that affected things.
Yeah, I would like to add some consideration why we choose concrete tiles rather than thatch, because we consider that the use of thatch would requires a lot of maintenance and replacing like after 3 to 5 years, and we saw a lot of building in Maseru also use metal corrugated zinc kind of roof, which is it's not very good for hot conditions. So we tried to find another material that will that have acquired a lot of supplier in Maseru location, which also have lower carbon compared to clay tiles, which is we found that it will be concrete tile. And maybe Jichen have something to add. Oh, no, okay. So as we try to simulate using concrete tile, is also provide a good thermal mass and resulting in a good thermal comfort. So we decide to use it.
Okay, super. Thanks for that very thorough answer and thoughts through the materials. And I should have said at the beginning, sorry, congratulations to all of you. It was really impressive, the amount of research and detail that you all went into. And this is so, so useful. And I'll say at the end what the next steps are and what we're going to do with all this information. But I just had a couple of questions for the other 2 groups. So group 3, you said that on the bricks, the fired bricks is what you went for in the end, but and you said it was slightly better than the compressed earth blocks, but not much. Can you elaborate a little bit on that? Because we're in the moment in the process of doing quite a lot of workshops on compressed earth blocks, because trees are obviously a scarce resource in such a deforested country, and there's a lot of problem of soil erosion. So I just wondered whether that was on thermal efficiency or on what grounds you kind of what your main motivation for choosing fired bricks over compressed earth bricks was.
Hi, let me give answer for this question. The fire brick, it gives better result on the thermal way. However, based on our research shows that its manufacture is harder than CEP. And the CEP is so common in the Lesotho. For this reason, we choose the CEP to reduce the price, cost, and embody carbon. But however, the fire bricks, the thermal mass is higher than CEP. So it gave better results.
Okay, interesting. Okay, thanks for that. And lastly, for group 2, I just wanted to make sure I understood correctly that you, on the glazing of the windows, you said that single glazing was better than double glazing. Did I understand that correctly? And if so, I know another group talked about secondary glazing. I think a few of you talked about that, but I just wanted to make sure I understood that correctly, because first of all, double glazing doesn't even exist in Lesotho. It's only made in South Africa. So but yeah, we're trying to also see how we need to sort of impact and influence the built environment to try and improve efficiencies on building materials. So if you could elaborate on that a little bit, that would be helpful. Thank you.
Thank you, Daniela. So we found out from the shoebox analysis that we try to, like, we have the shoebox model with one windows, and we try to implement different glazing type. And from the result, we found that the clear glazing, the result is quite like similar to double glazing. And actually the clear glazing one, the result is performed better than the double glazing as well. And yeah, and that's why we choose that one in terms of the cost and the availability at Lesotho, and also in terms of embodied carbon.
Okay, super. Thanks for that. So yes, costs I know is something that you didn't have time to go into much, because obviously getting costs online through desk research is very difficult in Lesotho, but that's obviously now our next stage that we're going to be working on and looking at, because we are looking for solutions of affordable housing, and so cost is key, and availability of materials locally is key. And I'm really pleased to say we've just in the process of signing a partnership agreement with Arup, with their Italian office, who are going to be giving us some technical assistance. So moving forward, with your permission, we're going to be sharing your presentations and the work that you've done, so that we can take that on board with finding, the ideal sort of designs, and probably looking at a modular sort of solution as families grow and needs develop over time. But you've really helped us a lot on getting things off to a good start. And so I just wanted to give you that update as well. And thank you so much for your work. The next stages are doing some cost analysis, looking at all of the research and results and the data you've compiled, with Arup to get a sort of an ideal design. And then from that, we'll be fundraising to build some prototype buildings, especially on compressed earth block. We're also doing quite a bit of work on the thatch industry with the ministry to try and the higher education colleges to get thatch as a more recognized formal sort of vocation. Because it's a dying trade, and it tends to be the elderly who have that skill and not being passed down. And so thatchers are getting fewer and fewer. So we're also working on that, as well as compressed earth blocks, and working on advocacy for hempcrete as well. So I'm sure we'll be doing more work with UCL, hopefully, Hector, with you and the rest of your team as soon as. But really wanted to thank you so much for all the work that you've done. It's really proving to be very, very helpful. And I think we've got a question from the audience as well that's just come in. I think we kind of need to wrap up soon. But they've got a question to Group 7. Did you look at aesthetic elements, or were you focused on the sustainability elements? I have a belief that architecture doesn't have to be alone, but rather act as a catalyst or a booster for Lesotho tourism by creating more sustainable, beautiful homes and cities. So Group 7, would you like to answer that question?
Yeah, sure. And apologies if we didn't actually put quite as much. We had quite a bit on the aesthetic side of things, and I think the architectural style that we saw in Lesotho, and massively agree, was really interesting, and had we love these geometric shapes. I can't remember what the name of the design type is, but where you've got the patterns copying out.
Tema, yeah.
Tema, yeah, exactly. And I think with a bit more sort of time, we probably would have been incorporating more of that into our design. I think the sandstone sort of presentation was a real key bit for us, just because the look and feel of it was felt very much grounded in the history of the country. as well. So yeah, I do hugely agree. And actually, we were trying to, I guess it was trying to look at that architecture that included that sort of design, and maybe less around the metal roof type designs that we've seen as well around the capital.
Thanks for that, Henry. And yeah, lesson here also for you to keep in mind is that the students working on this project were a mixture of different disciplines. And the main focus and impetus, I think, was on the sort of thermal efficiencies and a lot of the different climate changes, rather than the focus on the designs, which is going to be now the next stage of the work. But although there were some concept designs put together as well. So fantastic. Well, thanks again for everything and for your time today to present as well. Hector, I don't know if you want to say any concluding remarks before we hand over to Chris to close out the session.
Yeah, no, thank you, and Rice, for the opportunity. I mean, I think it's great that our students, and especially for me, and that they're doing their master, they're learning, but at the same time they are contributing. So the impact that they can do with their design, I think, is quite an important aspect of our program, or at least this module in particular. I believe that actually this has been quite an opportunity for them, and I'm pretty sure they're going to use it in the future as part of their CV, or who knows, maybe some of them want to go and travel to Lesotho and work with Rice at some point. So yeah, who knows? And just for sure, I'm really, really interested in continue working with you, Daniela and Chris, and with Rice. It has been a really great experience. The other thing is we have Valentina here, which is part of our team. So I'm going to make sure that next year, actually, she plays a role in this project. Absolutely. I wasn't aware until the end of the project that actually she used to be a Rice employee, or member. So yeah, great. No, thank you very much for your opportunity. And if people in the audience has more questions, please just send me or to the student any question that you would like to know. Okay, but thank you, Daniela. Thank you, Chris. And thank you to the students.
Yes, indeed. Thank you so much, Hector. And thank you to all the students and the amazing presentations. Really, really appreciate it. Dan has already said all the thanks and the gratitude on that. Also, I'm just emphasizing that we really appreciate your time and the contribution that you've made. And also, thank you to everyone who attended. Thank you for joining us today. Please do join us again. Next month, we'll be having another webinar on the 23rd. We'll communicate the topic. For now, be on the lookout for that. We'll also be sending this recording to everyone who joined us today. But please feel free to watch all our webinars and lectures on YouTube. Please do subscribe to the channel. On YouTube is Rise International. That's where you can also see all the works that Rise has been doing in the past years, even now and in the future. So please also follow us on our social media, that is Rise International, on Facebook, on Twitter, or rather X, on Instagram, LinkedIn, as well as I said, on YouTube. We'll share this video as well with everyone who signed up today. So really, really appreciate it. Enjoy the rest of your day. Thank you so much.
Thanks, everybody. Take care.
Thank you.
Bye-bye.
Bye-bye.